Okay. Okay. So first few slides, we have introduced ourselves, but I just want to tell you a little bit about our company before we go into the constructable BIM. So both me and Dennis come from a company called Trimble. Trimble is a US-based company, but actually we belong to a company that was acquired by Trimble many years back, almost 10 years ago. And that company is called Tekla, yeah, which is now the product name Tekla Structures. And well, talking about Trimble, the US company, actually we are a sizable company. We have almost 11,000 over employees all over the world, with the majority of part of our business is in the construction, right? We have some in transportation as well. You may not have heard as much as us, but I'll talk a bit more. So if you have heard about machine, excavator, or whatever that has GPS attached to it and can automatically move on their own and do the excavation, yeah, that is Trimble. All right, so they start out with Trimble started with a GPS and machine controls and things like that, and surveying. Very one of the biggest player in US at the time. All right, but over the last 15 years, we have started to build up, acquire and build up solutions for the construction. So now we have solutions that cover the whole, whether it's civil or building, or is it precast, is it structural steel, is it BIM, project management, even M&E. We have the suite of solutions there. But today, we represent the structure part. All right. So we are representing more of the structural part, but we still cover from concept to design, engineering to fabrication, and we are very strong in fabrication as well. All right. So I mentioned we belong to the structures, and the company that used to be is the Tekla. All right. So let me see. All right. And under us, we mainly focus on structures solutions for BIM. All right. We have analysis design software, as well as structural BIM, advanced BIM modeling software, and it's also collaboration software. All right. So it can be a multi-materials solutions. All right. You can see the different. If you actually, there's many of the especially iconic buildings are done using our softwares. All right. Tekla Structures, that is, right? And we are the leader in the structure steel. We're the leader in also the rebar and 3D. And now even into the bridges, right? You may not have as much because most of these people, especially contractors or maybe even downline structure steel detailers, they do not tend to go to the stage and market themselves as much, or even online or things like that, and also even subcontractors or fabricators, compared to architects who talk a lot about BIM, all those things, yeah, so you don't get hear about them, but be assured that most of the tall buildings in the world, many of the tall building worlds are done. Tekla has a part in it, right? Especially if it's structural steel, yeah. So if you're interested, you can always go to the Tekla website, take a look at our references, right? So so much for the introduction. All right. So what is constructable? All right, we'll talk about that. But actually, there's a strength of Tekla. We are the one well known for being able to produce constructable models and also tools to use the constructable models. All right. If I may, maybe you missed the. Sorry. Let me just go back a little bit. Yeah, so you can miss this picture. You can see this is the model of the Tekla structure steel, and this is the rubber, this is the rebar with the structure steel that I haven't inserted yet. All right, so if this actual work, how it looks like in actual work, yeah. So this as real as what it gets on site. So what's so important about that? That's what we are going to talk about in relation to BIM. All right. So for the next few slides, I'm going to just talk a little bit about constructible BIM using concrete construction as an example. As I mentioned, because we are going to go in depth, constructible BIM will talk about different disciplines of things, precast, even curtain wall, temporary works, bridges, RC structures, vertical structures, composite structures, all these are fabricated by different people. And so it has different, if you go down to it, the modeling will be slightly different. The concept is the same, right? It has different advantages. So we just take one concrete example. But since most of you have not have experience in BIM, all right, some of you have, all right. If you Google BIM, I'm sure you can find the definition. So I'm not going to, because we have limited time, I'm not going to go in there and define BIM. But generally, you know, BIM is it's basically a concept whereby you have data, a geometry that represent what you are going to produce, and then with data embedded in it. All right. In a very simple way. How they started everything, I'll give you as a homework to go and Google it, find out how it started, what's the definition of BIM, and also what are common users people use for BIM. All right. But BIM is building information. It started as building information model, which is just talking about model itself with the embedded information. But along the way, people talk building information modeling, which is the use of the model to improve the construction industry over the whole value chain. All right. But I rather talk about is what was it that what was the problem that BIM was trying to solve, or people advocate that BIM was solved. All right. I think what was the problem that make BIM something that people want to adopt? Let me know if you agree with me, is that there are some practices in industry whereby up to today is still a challenge for us in terms of the productivity as well. One is that over-the-wall practices. What I mean by over-the-wall practices is that between consultants, among the consultants, you know, structural architect, M&E, you know, they just do their part, architecture, and then they just pass over to structure. You know, they don't look at whether structure, they don't coordinate so well with the structure team. The structure just do whatever they, based on architect give them, and then they'll just do what the structure need, and then just quickly pass over to other consultants. Right? They don't check each other work, whether was there any, the work I produced, does it really link with the architect or with the M&E and things like that. But that design actually goes out to tender. All right. And because of time constraint as well. So actually contractor receiving tender documents that even for construction, even that is not really ready for construction. And also partially consultants are a lot of very limited time and also not paid to do constructable so-called design. So end up there's a lot of changes coming, and when changes keep coming and yet your construction has started, that poses one of the biggest challenge in the industry, and that's why you see people moving into precast, prefab, and things like that, so that you have to have the design done. All right. The second challenge actually is that everybody is, you can see from the chart here, when you have drawings, basically we are using 2D or we're using drawings, all right, traditional working, everybody do their work, but being not digital or being just 2D CAD, the information is just lines, polylines and curve. visually you can see it, but it doesn't tell you much. You have to read off the text from the 2D to human read it to understand, to interpret the 2D drawing. All right. And that information also cannot be easily shared. When I say information, meaning that particular data inside, all right, cannot be shared intelligently between software to software, between to another software for analysis or another software for ERP for production, or it cannot be shared so easily with other project management software example, all right, because it doesn't have the intelligence of it. And also we talk about quantity takeoff, a lot of people still using Excel at the time. So again, you take off from there and then you put Excel, but when there's changes coming, how do you link it back? So we call it the disparate information, partially due to format, partially due to media, partially due to the lack of interoperability format between the different softwares. Right. So when data like that is, we call it non-digital data, we cannot integrate the various functions together. All right. And people all working in silos and over the wall practices. So that makes one of the biggest challenges in the industry is that the information that's needed to do the work accurate, on time, coordinated, constructable information is not available, right? It's not available. So that's one of the biggest challenge to see that BIM was out to address as well. All right. But of course, the most layman one is that I can't see. Actually, it's quite funny that doing a construction building is not anything less complicated than any machines, big machines. All right. But we don't even have a visual of how it looks like in detail. Not the architectural concept visual, but a real prototype of it, of a model of it, and how it's like. And yet for 100 years we've been doing that, building it without having a full picture of it, right? But if we have that and we have the information in it, and we can share this information out and use this information for prefab, for into production, all right? And even before that, we can coordinate, make sure it's workable, having people from the downstream people to participate in the design process, make sure that whatever we design is constructable, can be fabricated, all right, and coordinated. Then I think the construction would be able to execute the construction, and then there'll be very little design changes. Everybody just focus on how to do the construction efficiently, and everybody actually save costs as well, right? Another point of this is to take note is that BIM, we talk about BIM, we always talk about the whole picture from the whole industry, but reality is that just 3 of you here, you work for different type of companies, all right, a different profession, and the BIM to you will use it differently from the other party, all right? So what does it mean to a contract manager? What does it mean to a quantity takeoff, cost estimator, QS? It's different from someone who work on site and someone who work in the engineering office, all right? And also business to business is different. You are a fabricator, you use it differently. Contractor, you will use it differently. Designer use it differently. Your benefits that you should be looking for is also different, right? So I talked more than needed on this slide, but I thought this slide was the most important slide that I wanted to share with you. Is there any questions at this point? I'll be happy to address them before I move on to the next slide. Okay, in the interest of time, I'll move on. Okay, another concept that you all need to know about is the level of development. All right. Again, Actually, I have a very nice, recently I just saw one nice article that explained this level of development in a very simple way. So I'll post that up in the LinkedIn group. So you please go ahead and enjoy it. Then I'll post it up there. Basically, level of development is in the BIM model, as mentioned here. You know, you develop over time from planning stage to design. Not day one you got this constructable model here, but it's over time that you build. All right, for obvious reasons, obviously the design need to progress as well. But over time, it's only good for design concept, but now it's good for detailed design, and then it's good for tender already, because it has the necessary, and then it's good for documentation, production, so that they can produce for tender drawings and for construction drawing, and then it's good to take off for planning, for purchasing, for your preparation of your work for your construction and execution of construction, and also good enough for fabrication. So all this has different stages and different level of development. It's important to specify or to know or to agree on what is this model suitable for. If you use a model that is at design stage and use your fabrication, guess what? Obviously, firstly, it cannot be used. Even you can use, you'll be wrong. It will never fit, right? So for those who are in the curtain wall or things like that, you know you are at the end point. You know what you design, what you put up is the final product. It cannot. If it's wrong, it's wrong. You have to go redo it, right? But in design stage, you are wrong. It's just a stroke of pen. You can change it, all right? But if it's at the fabrication stage, if it's wrong, it's wrong. It doesn't fit, it doesn't fit, right? So and that is the difference, all right? And same for estimation. At the before project or tendering stage, you are doing budgeting, you are doing costing, and if you're doing budgeting, but the quantity takeoff based on QS work, based on SMM, is not the actual quantities that you use to do the purchasing. The actual quantities basically is the actual quantities of what is needed. Maybe slightly different from the bills of material, the BQ. All right. So if I'm just throwing here a lot of things here, all right, but generally to share a bit more with the BIM, all right. So the level of development. So this is a BIM model example, right? And then your M&E structure steel, whatever you have, all right. So not all BIM models are done the same, right? If you want to go to construction, you have constructable BIM. Apart from the concrete geometries, we'll tell this is concrete or what kind of grade of concrete and things like that. All right. You also can use the model to do the casting, planning, or if it's that is the use of the model during construction. Right, but you need to know the embeds location so you can know the reinforcement fits in and can be installed. And you can call what the rebar needed, the bar bending schedule. You can either cut, so you can cut and bend on site, or your order cut and bend rebars, and you can also quantify them. How many of them is it? You also have temporary works that you can, if you want, you don't have to do it, but if you want, it can be done, and then you can better coordinate your work as well. And then whatever you've done, you actually connect it to your survey equipment, the robotic survey equipment, to do the auto layout on site to get it accurate. All right, so this is just an example, and then add in the rest. If it's structured steel, then you have bolts and wells, even molded. So all this goes to costing as well, and also go to analysis as well. And then you have M&E trade coming in and do the coordination as well. All right, so as I said, I'm focusing more on the reinforced concrete. So this is a reinforced concrete example, and a good example of constructable. Basically, the model is as good as what is needed, exactly needed, what is to be built. The data, the elements are represented as it is. The data is inside so that you can extract them out for use. You have tools to use it for their various purposes, for planning or for quantity takeoff and things like that. Right. First, you must have it inside the model. Otherwise, there's no way you can take it off accurately. All right. So, so this is what I mean. So one model constructible model. You use the model during construction. You can use it for quantity takeoff. It's very accurate. You use it for your scheduling or logistics. You can use it for pole planning and produce casting drawings specifically to the casting sequence and things like that. You can use it to do your formwork planning and detailing. And obviously you can use it to do your bar bending schedule, rebar quantities, and the detailing to make sure that it doesn't clash. You can even check the clash between rebar and rebar with other elements and produce the drawings. You can also account for the anchor bolts and clashes and also coordination with others. You can use it to do automation layouts, and then also use it to coordination for and bring it on site and use it for casting. All right, bring it on site means that the same information can be on tablets. But if you ask me, compared to the question I asked you just now, what are common users? Most people don't use it for this yet. All right, they use it mainly for drawings, documentation, and use it for clash detection between archi and like what you saw in the model here. Just generally concrete and then coordination with the M&E, the wall with the M&E, and then visualization, nice, picture visualization, and then produce drawings from there, and also try to take off from there. All right. So that's okay if it go up to the point of tender or just pre-tender, but once you go into construction and fabrication, then this model will not be good enough. All right. So let me just move on to the next one. So apart from being constructible, all right, when we talk about constructible process, there's two other things that's important. One is content enabled, meaning it carries more information about the element. If it's, especially with M&E, whereby you need to know the specifications. But what is more important also is connected. We talk about how disconnected the stakeholders are. So you have a nice model, constructible model, but if you don't share it or unable to share it, then it's useless because you're working with so many trades. All right. And everybody need to look at the same thing regardless of what software they are using. So connected data, connected people is very important. And that's why there'll be another solution whereby in the cloud, whereby you can coordinate between the various profession at different stages, and to bring even this constructible model there to help to track the status of the work and to have the information at hand. All right, whether it be on handphone, mobile, desktop, browser, or HoloLens, which I don't have time to go into. All right, so basically designer now can design, they can port the information analysis design over to a Tekla, to a model, constructible model in the case of Tekla. Then that model with the design rebar can be available, and you can start to do the detailing of the rebar plus the constructible model plus the coordination, and then send the information for fabrication. And then you can bring the information onto the site as well to verify, to do stick out, layout, and things like that. So this is the concept of how it can be used for construction. All right. So as I already have overshot the time, obviously, I'm sorry that if it's too much for you, but but what we do is that we will continue to learn. So if you're interested to learn more, me and Dennis is thinking of setting up a small LinkedIn group. All right, maybe starting in May or June, we'll start to post some for videos or workshop. He definitely will post it. Accessible this workshop, he'll post it there. We will also be posting guide on and links to free learning materials. Where else you can learn about BIM, constructible BIMs. And since it's a LinkedIn group, you can ask any questions. We have people who knows that guy inside the group as well. We purposely invited them so that they can answer any of the questions. and also among yourself, you can chat, and we'll be there if you have any questions. So you look out for this group called the BIM and 3D Detailing. All right, this is the link. Yeah, so look forward to you joining there if you want to continue to learn more. Obviously, it's not charging anything. It's just building up people who have the same interest in this. So that's the end of my sharing. So I'll hand it over. In the interest of time, I'll just hand it over to Dennis. Dennis, you can take back control for the sharing.
Okay, thank you, Mark. Again, good morning to everybody. So, can you see my screen now?
Okay, everyone, I will appreciate that unless your background is very noisy, you may need to switch on your audio because so that we can get the training going.
Or
We need to get some response on certain things because we don't know whether you are ready or not ready on the hands-on. And also, Dennis, for this round of workshop, I will not be, I'll be leaving this workshop now to hand over to you.
yeah,
All right.
okay.
So if there's you have any question about anything, maybe you can let me know later on. Yeah. So thanks, Kayang, Keng Soon, and Hui En. Hope that we have a chance to catch up in the future. If you have any question, you can post it up in the LinkedIn group. All right. Thank you very much.
Okay.
Hope I don't click the wrong button.
Okay.
I leave the meeting.
Yeah, thanks, Mark. And yeah, so guys, if you have some question or if you want to um, something like to answer as well, so you can also use our chat box here, so you can type your question in case that you miss something. So now I'm going to start with our workshop here. So basically, we sent you the link to download the Tekla Campus. So Tekla Campus is a free software for learning purpose. So this one you can use that one for, I think, for 45 days, and then that can be extended to I think up to 3 months. All right. So now what we're going to do is to model this model. So at the moment, this is the model that I have created, and I send this one to you as well. So okay, so let us go through this model first. So if you notice, this one is a 3D. Since we're talking about a 3D modeling software, so you can rotate, zoom in, zoom out. You can make it transparent by okay, rotating is just simply press the control key and then middle button of your mouse and then move, so that one you can rotate. Zoom in, zoom out is just simply roll this middle button, roll up, roll down, so that is the zooming. Then if you select the middle button of mouse and then click and then move, so that one is something like the panning. Okay, so that is the panning. Now if you want to make it transparent, so there is a command here. Control 1 is a control 1 is a wireframe. Okay, control 2 is a shaded wireframe, like a transparent view. Control 3 is a white. Okay, and then control 4 is a rendered view. Control 5 is a transparent view, and then it will just simply highlight once you select. Okay, so we go to the Control 4. So now here, if you have a huge model, we can also do the clip plane. So clip plane meaning you can just simply select this surface, and then you can make a section. So we call this one as a clip plane. Yeah, clip plane. So you can make a clip plane also on the side if you like. So if you notice, when you do the clip plane, you can see the information inside. If there is a reinforcement, you can see the reinforcement, and then also the sections like this. All right. And then if you want to remove that, select the scissor and then delete. Okay, so now that is how you navigate the model, and then by pressing Control P, yeah, Control P, so it becomes a plane view. Control P again, this one will become a 3D view. Okay, so now um, we can now start dealing with this model. I can simply delete this, delete everything, and then I'm going to show you how we're going to create this simple model. So basically, in Tekla structure, you have, okay, Control I. So in Tekla structure, there is a grid line here. So look, this grid line, if you double click the grid line, as you can see here, you have the coordinates. So this is where you start the model. When you create a new model, then you can have the grid line automatically by default. Then you can change the value of the grid line. So this grid line, if you notice here, there is a 3 into 5,000. So meaning, the meaning of this one, in x direction, this is the x direction and this is y. So if I may open my drawing tools, so this is the x, this is the x, and this is the y. So from A to B, that one is 5K. From B to C, that one is another 5K or 5,000, and so on. This one is 5,000. So the way you put the value in our x direction, so it must be 0, starts with 0, then space, then you can put 5,000 space 5,000 space 5,000. So that's how you put that one in the coordinates. Or if this one are constant 5,000, you can say 0 space 3 times 5,000. So that will be the value. So if I may erase all the drawing and then go back to this one. Okay. So look, let me just simply change this one to 0 6,000 by space 6,000 and then 5,000. So if I enter, look what will happen. So there is a changes in the uh, in the sp- in the grid line. Okay, the spacing of the grid line. So if I want to go back to look, if I type here 5,000 space 5,000 space 5,000, enter, so it will restore to the 5,000 5,000, and automatically this one will become 3 times 5,000. And then you will notice that the y direction is the same thing. So meaning the x and y, okay, just color pen. Okay, so the x and y, this one is, we call it as a relative value, relative. Okay, so this is a relative value, this x and y. Okay, so meaning it will start from where it ends. So from 1 to 2, 2 to 3, 3 to 4, and so on. So that is the relative value. It's like you're adding a dimensions. So now, okay, I'm not sure if you have, did you download the Tekla campus? Do you want me to go through this one and then, or or you want to do the hands-on? Because the thing is, anyway, this one is recorded. You can follow the recorded later if you like, so that I can continue on working on this model, and then of course I'm going to explain what are the commands that I'm going to use. So you can just simply follow on that particular commands later if you just want to listen to what I'm trying to model here. So no need for you to do the hands-on immediately. You can do the hands-on later once I upload the video and share to you the link. Okay, so now for our z direction, for the z coordinates, this one was taken differently. So look, if I'm going to z direction, so I can go to the view. Under the view, there is a using 2 points. There is this command using 2 points. If I click this command, okay, using 2 points, so pick this one and pick this one, so you can see the arrow. So control tab and then control P. So this is the elevation. So if you notice, for the elevation, uh the value here, okay, look under this edit, you can see the measure. So I'm going to measure vertical distance. So from here to here, okay, let me just turn on my snap. So from here to here is 3,000. This one and this one is 3,000. This one is 3,000. Oh, sorry. This one and this one is 3,000. Okay, now in elevation, we call this one as the absolute value. So meaning for the z direction, this is absolute value. Absolute. So absolute value meaning the value here must be must all oh, okay, the value on the coordinates, these coordinates must be starts always from 0, from here. So meaning from FFL or finished floor line to first floor. So that one is 3,000. 0 and then space, then 3,000. Or if I can rewrite it here, so 0 space 3,000. And then space, again, the second floor is from the floor line to the second floor here must be 3,000 plus 3,000 is equals to 6,000. And then lastly, this one to the roof is 9,000. So that's how you write the value in Z direction. Okay? So erase all the drawing and then go back here. So if you notice here, so 3,000, 3,000, 3,000. So you can see here 0, 3,000, 6,000, and then 9,000. So it will be wrong if you put here 0, 3 times 3,000. So that one will not work. So you will not able to see your grid line in your elevation if you put that way. So again, X and Y is a relative value. Z direction is a absolute value. Okay. So I can close this view now. And then since I have now the 3D view here, we can just simply, okay, the label is here, A, B, C, D, A, B, C, D, and then 1, 2, 3, 4. And then this FFL first floor is what you have seen earlier. So on the elevation. So now what we can do is we create the view from each grid. Okay. So I'm going to select the grid line, right click on it, and then here create view along grid lines. So if I click here along grid lines, and there you go. So you can see here create. So once I hit create, automatically it will give me the different grid lines. So if I open all this one, so as you can see here, it will create all the grid lines. But again, in Tekla structure, there will be a maximum of 9 views to be shown in your window. So maximum 9 views only. Okay. So if you want to open another view, then you can just simply, okay, I'll put this one as a tile vertically. So under this window, there is a tile vertically. So you can see here, it will be tiled in your window. So you can see all the views that you open, 9 views maximum. So if you want to open the grid A, you cannot open that one unless you close one view and then open the grid A, and then it will be there. Okay. Now, if you want to close the what do you call that, the window. Okay, just hold on. Uh, sorry. Uh, just hold on. Sorry. Where is that one? Oh, okay. Okay. So right. So once you want to close the all the windows, you can now go to this under this window and then close all window. And then if you want to see control I again, control I, so you can see the view, the name views. So here you have the 3D view. Okay. So you can go back to the 3D view again. So this is how you, I mean, when you close the window, it's not necessarily off, but if you press control I, so all the views on the left side will be hidden. So once you put that one on the right side, it will be visible again in the window. Okay. So close it and then it will be hidden. So if you're not using it, then you just put that one on the left side. Okay, so far, is there any question? Again, if you have any question, just let me know. You can type that one on the on our chat box. Okay, so to continue, all right. So to continue, we can now add an element. Let's say, for example, we start with our concrete here. So under the concrete, we have the footing. Okay, so once I double click on the footing on the right hand side, okay, so here on the right hand side, you can see here the pad footing. So on the right hand side, this is the properties of the footing. And then as you can see here, you have the profile, the size of the footing, and then you have the material, you have the class. So class is something like the color. If I want to put that one as a color, let's say 1, okay. And then here, the position, vertical, and then the horizontal position, and then you have the top and bottom. So here I can say that one will be a cast in place. So the pad footing, if I change this one to maybe 1500 by 1500, okay. So this one is parametric. So 1500 is a square one. So meaning if I type here 2000 by 1500, then it still work because this one is parametric. If you go to this profile, under this profile, as you can see here, these are all the profile database in Tekla structure. So as you can see here, we are using this HNB. H&B. So 1,500, 1,500. So there are many profiles there available. At the moment, we're going to use this. Uh, Actually, this one it's called plate profile, but you can use this one as a slab or as a footing. And as you can see here, the material of the concrete is C40. Okay, and then the class, and then if I pick here, so as you can see, automatically there will be a 3D model. So when in AutoCAD, if you want to create a 3D model, you have to just create this rectangle and then extrude. So this one just simply pick point and then you have a 3D model. And then this 3D model is not just a 3D view, but of course here, okay, let's say for example, top is 0, this one is 0 on the global coordinates, bottom is negative 750. If I type here negative 800 and then enter, so it changed negative 800, the height of the footing. Now look, if I inquire this one part, so immediately I can get the properties of this. So I can even get the report. So what report? So let's say, for example, I want to see the area of this footing. So I can get the area. I can even get the volume of the concrete in this pad footing. So immediately the system will calculate for us the volume, even the weight of the footing. It will give you the weight. So you don't have to calculate that one using your calculator, because the Tekla structure will able to give us all the information that we need for our let's say fabrication or for site. Okay. Now, if you're happy with this one, you can just simply select again the footing, and then you can just simply click again this intersection, and there you go. So it's a very simple way to add the footing. Just simply pick 2 points, pick 1 point, and then the footing will be placed there. And then if you uh, if you select this one, we have an option to copy. So if you right click, copy linear. So copy linear, meaning you can pick from this point and then select the direction. So I'm going to copy to this direction. Look, that one is 5 meter. If I click here, automatically the 5 meter will go to the dy, and then the number of copies, how many? 1, 2, 3. So you type here 3 copies and then copy. So you're going to have all the pad footing to this intersection. You can also just if you like, if you don't want to copy, you can just simply click the footing and then pick one by one. So that's the same thing. All right. So anytime you can change. Let's say, for example, this 4, I want to change the size of this one to 1 2 by 1 2. Enter. So you can change. You can even change the color of this one only. Yeah. So you can do that one immediately. And then look, if you inquire this one again, the information of this one is totally different. See, the volume of the concrete is 1.5152, and then this one, if you inquire, this one is volume is 1.8. So as you can see, to check the information, you can always inquire in the element. Okay, and then the next one is we can now add the column. So for the column, just double click again, and then you can see here the column 400 by 400. So that one, I can accept that one. And then let's say I'll choose number 11 here. Then here the top will be 3 meters. So 3 meters meaning this will be the height of our column. So remember, in our grid line, the first floor is 3 meters, so it will stop the column there. So if I click here, 1, 2, 3, 4. So that one will be the 3 meter. And then if I copy, again, copy special linear. So the value earlier are saved already. So all you have to do is to hit this copy, and then you have now this column. Okay, and then we can add now the beam. So under this beam, so select the beam here, and then under the properties of the beam on the right hand side, so you can change the size of the beam here. So let's say instead of 600 by 230, I'll just use the 600 by 400. Okay, and then the beam, I'll choose this color. So select 1, 2, 3, and then 4. So I'm putting it. I use the double click. So 1. Okay, click here 1, and then double click here so that I can start again. Click the. Oh, sorry. Again, I missed that one. So here I click here, and then from here to here. So by simply rotating that one, I can just simply select and then copy special linear. So same thing, I can just simply copy that one to have that beam, and then here I can rotate to the X direction, and then instead of Y, I will make it 0, and then going to the X direction to the left, it will be negative 5,000, and then copy. So you have now this frame. Okay, and then if you're okay with this one, I can just simply copy this, right click, and then copy special linear, and this time this will be copied to Z direction, so 3 meters, and then copy. So I have now this framing. Okay, so now this one is made of concrete. Now let's say I want to add a steel structure here. Okay, I want to add a steel structure. Actually, the good thing with Tekla structure, even I started this one with a steel, with a concrete. You know that I can simply copy this part. Okay, copy this part, and then again right click, copy special, linear, and then copy, delete duplicate. Okay, so what I will do here is I can just simply change this value. Okay, I select this one, change this value. I will go to the profile. So meaning from concrete, I can just simply change this one to a structural steel I section. Let's say, for example, UC, and then I can use the UC 305 by 118, and then apply, and okay, and then change this color to, let's say, red. And then this one, the material, because I choose the steel, I can now change the steel material here. Let's say S7JR or S275. Apply, and okay, and then modify. So look what will happen. So this one will become a structural steel. Now, if you want to rotate the structural steel, the planche must be on the other side. So again, by simply selecting all these element, and then look, once I select this element, uh, and then I go to the properties. Oh, sorry, select this column. So you will notice here automatically it becomes a steel column here, steel column. So here, if I want to change this one, I can type this one as C, for the part, and then this one, instead of front, I can put that one on top and then modify. So look, it will be rotated there. Okay, and then for the beam, same thing. I can select all the beams here. Yeah, select all the beams. So under this beam, I can now change this profile. So instead of 6 by 400, again, I'm going to use the I profile here, UV section, and then I can use the 305 by 165 by 40, apply and OK. So I can change again this one to this material. I will change again to steel material. So S275, apply. And then maybe I can change the color to 3 and then modify. So there you go. So you have now the what do you call that? The beam. Okay. All right. So let's say, for example, I have another. Okay, look. If I select this one and then copy, I can use the simple copy command, not necessarily the copy linear. So I have another copy option. So I'm going to copy from this point to this point. Okay. So look, but this time I want to make this one as a slope. So to make this one as a slope, I can just simply select all of these elements, and then by simply selecting the handle, this handle, the node, okay? I can select the node alt by pressing the alt key and then control alt key and then hold and then make a window. So look, I selected all the node. So now what I can do is right click and then move linear. So meaning I can move this one Z direction 1000. I will move 1000 and then move. So look what will happen. So I have now this uh, slope beam. Okay, so I can have now the slope beam. Now, if you want to make it uh, steeper, again press the alt key and then select, right click. Sorry, alt and then select window and then move linear. So I can add another 500 millimeter and then move. Ah, it doesn't move the, okay. So I can just simply select this and then alt key and then, again, alt key and then select, select the handle of the column and the beam and then here, move. Okay, there you go. So you have now the slope here. Okay, so this one is now the what do you call that, our geometry or the structure. Okay, so this is the structure now. So now, enable for us to do the details. Of course, we can do a lot of details here. So let's say, for example, first, maybe I'm going to add a connection for the concrete, so that at least you have the idea how we're going to add reinforcement to the concrete. So we make it transparent. Okay, so we're now going to add a connection. So make it transparent, and then under this application and component, as you can see here, I can simply type here footing. So footing, it will show to us all the footing connection or component. So we can use the pad footing number 77. So if you double click on this one, if you double click on the pad footing, so as you can see here, all right, double click. All right, so you can see here that there is a, sorry, let me just close the window. Cancel. Uh, all right. So here, as you can see under the pad footing, you have now the primary bar, the secondary bar. So primary bar meaning you can specify the size, the thick, the diameter of the bar. This one at the moment 16 bar, and then you can see the spacing 200 by 200. So here you have the zoning. Okay, you have the attributes. So at the moment where I'm going to use the default one, apply, and okay. So look, if I click on this footing, see, it will give me the reinforcement already in the footing. So now if I select this one, let's say this one, I'm going to add this reinforcement to one of the grid. Okay, so that you can see how it works. So just simply, okay, look, the good thing with this is if even I click on the different size of the footing, that one will work. And also, let's say for example, this one, this footing, I change it back to the same size of the other footing, 1.5 by 1.5. Okay, and then modify. See, so automatically the reinforcement uh will change. Okay, so that's how the system works in Tekla structure. Now, let's say here I want to add now the starter bar. So starter bar, this one, the starter bar. If you double click on this one again, you can change the location. So instead of 500, I will put here 400 because 400 is the size of my column. So the cover thickness, and then here it will extend up to 800. Apply. So look, if I select now the footing, so automatically there will be a starter bar placed there. So that is the starter bar. So that one is to connect the footing to the column. Actually, this one we can change a little bit. Let's say in the location we can make it 350, so that our reinforcement will not be collide to the reinforcement of the column will not collide to the reinforcement of the or the starter bar. So click OK. So if I apply that one now here, so as you can see here, here, and then here, you can see the reinforcement. Okay, so now to continue, we can now add the reinforcement to the column. So just simply type here column, or I can type here the number, let's say 83, if I'm not mistaken. Yes, 83, rectangular column reinforcement. So you can take note of that one later when you try that one too on your own. So just simply double click on this, and then again you can specify uh, the size of the reinforcement, the stirrup spacing. Okay, so as you can see here, you have now size 25. You can make it 20, and then the bar end, the position, the intermediate link, the stirrups. So you can see the stirrups. We can make it 200 spacing for the stirrups. Apply. Okay, look, just simply select the column, and then you can have now this reinforcement in the column. So column, column, and then column. All right. Now, I can pick on the top column as well. But the thing here is there is no connection between these two columns. Okay, so meaning this the first column I can extend the main bar so that it will be extended to the other column. So if that one is the case, you go to the bar end, and then here, as you can see here, I can use now the cranking. Okay, the cranking, and then under the cranking, so here, this instead of negative 25, I'll put here 1200 and then modify. So there you go. So as you can see here, this one is exaggerated cranking. So maybe we can just simply put, okay, so let's say this one is 200 and then this one is 200. Modify. All right. Oh, sorry. So maybe this one is 0. Modify. Okay. And then this one is 50, 50. So something like this. Okay. Sorry. So there you go. So as you can see here, okay, maybe we put a little bit more, 65 and then 65. Or sorry, 60. Okay, so now that one is okay now. So I'm going to apply this. I think it's make it 55. Yeah, this one is apply and then okay. So this time, sorry. Since this one is already existing there, all I have to do is to open this component, and then what should I do is select all the existing reinforcements. So this one, ship this one, and then this one, and then modify. So once it's modified, so this one will be changed. See, so that one is connected now. Okay, and then for the connection of the beam, okay, for the connection of the beam, I can use number 63. Take note this one again. So this one is for the beam reinforcement. All right. So the beam reinforcement, similar thing. If you open the component, so you can see you can change the value here. So let's say I'll put here 20. And then the hooks, the stirrup spacing. Okay. So let's say I'll put here 200 as well. Apply and okay. So all I have to do now is to select this beam. Yeah, that beam. Okay. And then here, if you notice, the connection here is for the CIP, but this time I can add a different connection between the column and the beam. So let's say I'll use the Corbel connection. So if this one is a precast one, so Corbel, so meaning the beam will be seated to the Corbel in the column. So if you notice here, see, just simply select the column and the beam, and you're going to have the Corbel. So if you want to change the Corbel size, you may do so here. Let's say I'll put here 11 to make it the same color as the column, and then uh, under the here I can put here 200 and then 200, modify. So that is the Corbel, or maybe 250. Okay, so this is our Corbel. This one also 200, smaller one. So if you're okay with this one again, apply, and okay. So all you have to do now is to select the column and the beam. So control for column, beam, column, beam. So column and beam. There you go. So as you can see here, oops, sorry. So I can select this one and this one, this and this. So that's how you add the Corbel. All right, so now we have already the connection for this. So I'll just redraw this one and then Control 2. As you can see here, you have already the proper connection for the column and then the beam. So this time we're going to move on to the connection in our column. So in the connection of our column, we add the base plate here first. Okay, the base plate. So what will be the base plate? So here, Control 4 again. So if you notice here, I can just simply add here base plate. So and then I have now this let's say base plate 1004. So this time, this one is for the steel connection. So if I pick the part, so let's say my plate size is 20 thick, and then the parameter general, okay, let's say I'll put here 6, and then the bolt, okay, no, the bolt position must be inside. Okay, so meaning uh, I'm going to put here 2, and then let's say 100, then this one also 2, and then 100. So apply. So pick the column and then pick the position. So as you can see here, that is the position of the bolt. So if you want to, by the way, this one, if you want to isolate this particular section, you can just simply select and then right click, and then here you can see create 3D view of part. So meaning you can isolate this particular connection only. Okay. So now if we want to check the position of our bolt, okay. So if you notice, even I put that one on the bolt, it creates the anchor rod. Okay, but let's check first the position. So instead of 100, I can change this one to maybe 150, and then modify 150, modify. All right, and then okay. So here I can put here maybe 120. Okay, and then for the picture, if you notice here, if I want to put here an additional 10 and then 10 for the welding, so that one will be extend to 10. It doesn't. Okay, maybe negative. Yeah. So here you have a negative 10. And then for the for this, you can go to the part. Actually, this one you can inquire the size of the column. As you can see here, the web is 307. Then if this one is 310, then 330. So the width, I can put the width of the plate as 330. No, there's no width here. So meaning I can just simply put that one here under this one. Maybe I'll put here another 60 and 60. Okay, select this one and then modify. Okay, so it's not enough. I'll put here 80 and then 80. Modify. Yeah, I think that's good enough for the column. Okay, so if you're okay with this one, then uh, for this anchor rod, so here you have a choices here. Let's say I'll use this one and then modify. No, this one, just a straight one. Yeah, so that one is your anchor rod. Or actually, this L shape must be okay, but I need to put that one on the bend to the outside. Yeah, something like this. Yeah, this one should be okay. So if you're okay with this connection, all you have to do is to apply and okay. So meaning for all the columns, I can simply select this one and then look, if I select these two columns and then select one position, so it will add the base plate to the column. Actually, even I select all the columns here, even these columns are different size, then it will work. So if I pick one position, then here it will create the connection to all the columns. So Control 2, as you can see here, you have now the connection for all the base plate of the column. So now let's go back to the let's continue with this connection. So here, if I want to have a hunch connection here, I'll type number 40. So hunch. Again, open this hunch connection. So you can see here, you have the parameter again. So let's say don't want this stiffener. You have a general. Let's I put here to 6 again, color yellow, and then the hunch. So as you can see here, I have the 500 and 300 here. The bolt, okay. So there's a bolt information there. So but here under the this one, I'll put here 0, apply, so that it will be flashed to the top of the beam. So select the column and select the beam. Then you can see that there is a hunch. Now, in Tekla structure, okay, in Tekla structure, we do have this option to do the class check. Okay, sorry. Let me just show the bolt modify. Okay, so if I select this and then select this part, sorry, show only. Okay, select this one and then right click, class check. So this one will give us a warning that something is clashing. So let's say, for example, if I press Control 5 and then Shift 5. So if I select this beam, so meaning this beam to this, there's some minimum requirement of the bolt, okay, to the plunge. So we need to adjust the bolt. And here, this hunch. So this one not necessarily is clashing, but the problem here is the range. You cannot tighten the bolt here because of the slope here. And then column and beam. So meaning this column and beam doesn't have the connection yet. That's why there is a uh, clash. Okay. So in that case, we can now go back to this component and then I can change now the sorry, I can change now the position of the bolt here so that we're going to clear the clashing. Okay, so now uh, under this bolt, here from, let's say, from top, and then if I type here 100, modify, zoom in, so this is considered as the top. So I type 100, and then this one, I can put this one as middle, and then here I'll type here 2 into maybe 80. Sorry, we can make this one as 3 into 80. Yeah, so that one will be more spacing. Okay, so now that we are okay with this, again, we're going to apply this one, and then select again the hunch, and then select this column and this beam. So you have now the hunch. Now, for this connection, we can use the connection 187. So again, double open the connection, and then we can do some adjustment. Okay, so from here, let's see, plate. Okay, let's say 10, and then the bolt. Instead, I will put only one, and then the plates here, I'll choose this value, and then for the bolt here, so okay, the picture I'll put here 10, and then the bolt, let's say middle, so I'll put here 3, and then 80 again, and then this one should be 35, 35, then 35, and then this one is 35. Apply. So select now the let's say change this one to 6. Apply, and then change, select the column, and then this beam, and then you can see here I have now the this connection, shear plate connection. So apply again, and then select this one and this, so you have now the shear plate connection. Now there is one thing that I need to um, clear here, because since, okay, I'm going to apply this one also here, but there's an issue here because of the slope here. I may change the height of the column, extend a little bit. So this column, I'm going to add additional maybe 100. So let's say 9,100, and then modify. There you go. So that I can now add the end plate connection here. So I'll type here end plate connection 144, end plate, or you can type end plate here. So to connect the column and this beam, so as you can see here, again, open the end plate component, and then this one, the plate, let's say 15. The picture here, I can type here instead of negative 10. Okay, let's say negative 10. Apply. Let's check first. All right, so negative 10 should be okay. But the thing here is, okay, so there's one thing that I need to change here. Uh, the bolt, I can add here another, let's say 3, and then modify. Okay, but the thing is, I don't need to make it as a middle, because I need to clear that one to the steepener here on this type. So here I will say 120. Let us check 120. Okay, so that 120, and then 3 into 70. Okay, so maybe this one is a little bit tightened, but I think should be okay. And or maybe this one I'll put here 110. Okay, there you go. And for the here, I'll type here 120, 2 into 120, and then 40, 40, modify. All right, apply. And this is our connection for this part. So we will just simply copy that one to the other side, this ib. But of course, this time, see, this one is it will fall to the bottom. So this case, I need to change the first downhole here, 60, modify. So there you go. So okay, so now you have this withdraw. So you have already the model. But again, what I did here is only for um, modeling of our concrete body, and then the steel, the geometry, and a few connection. So we can add more items here. Let's say, for example, I'm going to add a purlin here. Okay, so let's add a purlin, and then later on I'm going to add a cladding. Okay, so we will add the cladding here. So first, let's add the purlin. So to add the purlin, I can model the purlin here by simply changing the okay. I can go back to this grid one. Okay, under this grid one, I can create a roof plan here, a true roof plan. So new. So I can save a true roof plan here, a true roof plan. Then this one is, let's say, 500, and then 500, 500, apply, and okay. So pick here, and then, oh, sorry, using this. Okay, so this one now is the true roof plan. So under this true roof plan, if you notice here, so this is the true roof plan here on the right side, and then I need to change the UCS. The UCS, I can pick on the parallel view. Look, if I click here, this UCS, okay, this UCS XY will be transferred to this position. So see, so that one now is the top of the beam, and then having that UCS, I can now let's say offset a 300 millimeter here. So I can use my construction point. This one is a long extension. So let's say here 300, apply, and okay. So pick this point to this point. So I have now this 300 here, and then additional where is the okay, cannot see the okay. So let me just change this one to work plane. Oh, I cannot find. Okay. So what I will do, since the grid line doesn't extend, I can use my construction line here, and then put it straight. And then this time I can now add extension point here. So let's say from here another 300, and then this one I'm going to divide this one to, let's say, 1, 2, 3, 4. So still under the edit, go to the points, And then here I have the online. So I'll type here 4 points, apply. So meaning I'm going to divide this from this point to this point. I'm going to add 4 points, and that one will be my division. So here, if you notice, if I measure this one to this one, so our purlin distance is 893 to each other. So that one will be our purlin. So now I can add the purlin here under the steel. You go to the BIM. So I will type here purlin, and then under the profile, I'm going to use the C channel. Okay, I'm going to use the C channel. Let's say PFC 180 by 75. Apply and okay. And then let's say use the other color. Say 8. Okay, so this one will be the purlin. So pick one, and then here perpendicular 5,000. So look, now as you can see here, okay, it will go along with the slope, but of course this one we can change the rotation. So if you select this purlin and then select this contextual toolbar, so you can see the positioning here. If you pick uh, this circle, okay, and then move, see, I can put it this way, 270. Okay, and then the handle, I'm going to put this handle to the edge of the purlin, so I'll just click here, or this one, yeah. And then okay, so if you notice here, it will be placed on the top, but of course I need to adjust this one. Front, I put 10 millimeter, modify, yeah. So there's a 10 millimeter adjustment to the top of the steel. So now, if I'm okay with this, I can just simply right click, copy special, linear. So from this point to this point, and then 1, 2, 3, 4, 5. 5 copies, and then you have now the purlin. So now I can close this, and then here I have this purlin here. And then change now the UCS back to the original. Go back to the work plane and then click here parallel to XYZ and then click change. So the UCS goes back here, and then this purlin, I can just simply I can select all the purlins and then copy, right click, copy, linear, clear. So this one is negative Y, negative 5,000, and then how many? 2, and then copy. So you have now the purlin there. And of course, once you have the the purlin, so you can also add the again select the okay, look, if I select the purlin, automatically it will give me the rotation or the angle of the roof automatically placed in the purlin because I used the UCS earlier. So now if I want to add the the girt here, so I can use now the steel. So again, steel beam. Then here I will type here girts, and then same thing. I will just okay. I will from this point control, and then 300 uh, control, and then I need a 300, and then here 5,000. I can just simply type 5,000 from the keyboard, and there you go. So now here I can rotate again, and then change the position, and then that will have a 100. Okay, so if you're okay with this one, I can just simply copy linear. Okay, and then this one, this girt, I'm going to copy going up. Let's say 1 meter. Maybe how many? 1, 2, 3. Let's say 4. Let's see. Okay, there you go. Okay, so that's how, or maybe I'll just adjust this one a little bit. Move special. This one, let's say negative 200. Modify. Oops. Why it change? Doesn't change. Move special. Move. Okay. All right. So I hope that one is clear. All right. So now I have the purlin, and then I can now add the connection. So for the connection here, actually there are ah, okay. I think this one is wrong. Actually, the clit should be on the other side, but let's see. Actually, this one should be. Oh, actually, it's wrong. Anyway, it's okay. Let me just put the clits on the top, but actually the clit must be on the other side. But anyway, so to save our time, I can use now the connection number. Let's put it on this way. I'll use the connection number 1. Okay, this one. So if I pick this column and this 1 and 2, middle button of your mouse, then there you go. So as you can see here, I can change this one to all right. So the clits, I'll put the clit as angle let's say 180 by 80 by 6. Modify. All right. And then the bolt is I'm going to use the 12, and then the position of this one must be okay, the picture here I'll put here 5. Modify. Okay, and then the bolt here, this one is welded to the rafter. This one must be 2, and here it must be 90. Okay, and then this one must be 30, and then 30. Okay, and this one 2, I'll put here 100, and then 40, 40. Modify, and there you go. So perfect. So I have now the clit connection. Modify, apply, and okay. So now I can just simply add that one by simply selecting this rafter. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, and 3. And how about here? This one, 1, 2. Okay. So meaning, let us adjust this one. So handle, right click, and then move. So from this point to, let's say, 850. Yeah. So this one as well. Move. Okay, there you go. So if I add this one here, 1, 2, middle, 1, 2. So it's also works even only one beam here, as long as this one is extended. So this one, I can also add that one here to connect in the girts. So that will be the girt connection. And then this one, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 1, 2, 3. All right, so that's how you create the connection for the purlins and the gears. Okay, now what happened is we can add also the cladding. Okay, so let's say, for example, we have a GI sheet cladding, or maybe we have a glass or whatever, aluminum. We can also add that one. As you notice here in Tekla structure, we handle a multi-material element. So meaning I have the concrete, I have the reinforcing bar, I have the steel. So that one, we can use a multi-material. In this case, maybe I can just simply uh, show you how we are going to open the what you call that. Just hold on. I need to get the an AutoCAD drawing. Okay, so I have this AutoCAD drawing. This one, roof. I'll copy this one, and then I'll put that one on the model folder. So paste it here. So this one is the AutoCAD drawing of a roof. Okay, so meaning this profile is not available in Tekla structure, but in Tekla structure we can read the AutoCAD and then convert that one as a Tekla structure element. So under this one, I can put this DWG, double click the DWG, and then here, as you can see here, parameter. Now, remember the DWG group that I've shown you. So as you can see here, I can call that one roof, this one, and then click OK. So I can put a name. So let's say this one is a TW. Let's say TW1000. So that one is our profile name, TW1000. And then under the profile attributes, I will put question mark because that type is not available here. So I'm going to apply. So look, if I click from this point to this point, so this one will be the root from the AutoCAD. Yeah. So I have now uh, this roof, and then I can use this one as my cladding here in the girt and also the roof. So I will just simply double click on this one. As you can see now, it is saved already in the in my library TW1000. So what I will do is from here, okay, from here I'm going to use the beam. So under the beam, I'll put here TW1000. Okay, and then I will name this one as, oh sorry, TW1000, and then I will name this one as let's say cladding. and then I can use the color okay, don't forget to save your work. Okay, let me just okay, interrupt that one. There's some. Okay, so now beam cladding, and then change this one to what color? So let's say I will use a color 5. All right, so let me just put it this way first. Okay, so from here, 1 and then 2. There you go. So this is the cladding, but I want this one to be on the other side. This one, yes, okay. So there's already a 10 millimeter. I'll just put here maybe 5 millimeter only. Okay, or sorry, it should be 0 because that will be a self-tapping screw. Okay, so we're okay with this one. And then here, I can also add this one from this point to this point. So let's say I'll put 4 5. This one is 4544. I can put that one as 4 uh 4650, or no 47. Haha, yeah. Oh, okay. This one is actually, sorry. This one is wrong. This one must be okay. Just hold on, because this one should be on this one is wrong. Okay, so I need to rotate this one. Yes, it should be. Whoa. Yeah, 90, and then yeah, something like this. Okay, so this is the correct one. This is the correct one. And then this one must be rotate as well to this. And okay, there you go. So this is the correct one. All right. Actually, this one needs to be 0. And this one, I can move a little bit from this point to this point. Let's say 250. Yeah. So this one as well. I can move this one going up 200. Okay. So there you go. So now you will notice that okay, let's say for example in this case, some of the structure they put something like a trimming here, trimming. So let me try to put a similar thing here, and then we'll make a curve. We'll make a curve uh, roof here. So what I will do is this: select or add a construction line. Add this construction line, and also this construction line. Edit. construction line. Okay, so that one. So now, enable for us to create a curve one here. I can still use this value, but this time I can use the polybeam. Okay, the polybeam. So same value, but use the polybeam. So in the polybeam, I can just simply click here 1, 2, and then 3, and then middle button of your mouse. Okay, so as you can see here, I can just simply change this one to yes. Oh, is it? It's some. I think it's not. It's not properly placed. Okay, so let me check if I can rotate this one. 270. It's is it still? Mm, okay. Wait. Again. So from here, because the yellow is from here, so meaning double click again this one and then polybeam. So I can start from here, this one, and then this. Yes. See? Okay. So now this one is too sharp. I can just simply change this one to rounding. Let's say 300. All right. Or maybe 400. So this one need to move a little bit. 100. All right. So there you go. And now all I have to do is select this and then right click, copy, copy special, linear. So from here, okay, I'll go to this side much easier. So okay, so this one must be placed here 1000 and then how many? So let's say 10. All right, so that is the cladding side. Okay, so I think that's all for our modeling, and this time around, we can now give you the okay. I'll save this one. So this time I can run the numbering. Okay, run the numbering. So after running the numbering, if you want to get the bill of material, okay, the bill of material. Let's say, for example, the bill of material for the steel structure. I can select all the steel structure now. So from here, I can select all this steel structure, and then under this report, you can see here there is the assembly part list. So if I create from selected, so look, these are the assembly part list. So beam, column. So in column, what are the things connected to the column? You have the plates, and these are the columns for the rafter. So as you can see here, these are the things connected to the rafter. And then also, that is if you want to get the part list. Okay, so here you can see that there is a part list. You can also create a part list in XLS or here if I select, let's say create from all, this one will create the part list using the Microsoft Excel. So no need for you to convert. Automatically, it will create to Microsoft Excel. Say yes. And then here, it will give you all the list of your the part. Okay. So as you can see here, beam one. So these are the list. You have the weight, and then you have the total number of quantity of the member. All right. And not only that one, if you want to get the number of bolts, since this one there are some bolted connection. So here under the bolt list, create from all. So as you can see here, these are the bolt needed inside. So you have a 12 diameter, 20 diameter with a size of 35 length, 45, 65, and 70. These are the quantity. So no need for you to count one by one. So imagine if you're going to count this one by one, it takes a lot of time. So here, in no time, you can get all those information that you want. And let's say, for example, you want only the number of this cladding. Okay, you want only to get the number of this one and then the details. So under this still under this report, under the report, so you can still see here the part list and then create from selected. So here you have the cladding. So as you can see here, the grade and then the length that you need. So not only for the other, I mean, column beams, so even the cladding or uh, like what I've said, the bolt can get. Now for the concrete part, so if I select all the concrete here, and then I have the cast unit list. So here, cast unit list, create from selected. So these are the cast unit, all the concrete part. And then if you like to see the cast unit rebar list, so this one is, yeah. So let's say beam. These are the bar bending. These are the rebar needed for this beam. Okay. There you go. Yeah. So that one is after you create the model, you can get the report. Now, let's move on to the creation of the drawing. So for the creation of the drawing, you don't need to create that one manually. You don't need to draw that one manually. But because we have already the model, we can create the drawing immediately. So let's say, for example, in this type. Okay, so let's say we will create the general arrangement drawing first, or the erection drawing. So for the erection drawing, let's say uh, I'm going to create a grid one, the grid one, and then the what else? The grid one, the plan at elevation one, and then the 3D view, and then uh, the grid D. Okay, so look, go to the drawing properties and then select the GA drawing. Under the GA drawing, I'm going to select the standard and load, and then I will type here erection drawing. So under the erection drawing, I will select the layout. I would say to use the GA and then specified size, A1, apply, and OK. And then under the view, I will use the maybe a 75, which is the scale. Okay, apply and OK. And then the part mark, or sorry, the part, the appearance, I'll put here yellow, apply and OK. And then the part mark, here you see the profile, and then under the general not visible, okay, the main part, secondary part, no need, apply and OK. And then Now let's create now the drawing. So look, create GA drawing. So I would say this is the 3D view, something like this, 3D view. Select the 3D view, select the grid one, and then select the, let's say, first floor, and then select the grid D. So these 4 drawings, I'm going to put that one in one drawing sheet, open the drawing, and then create. So here, um, the system will automatically create the drawing for us. No need for us to draw one by one. Okay, so you will see here, creating the drawing. There you go. So this is the system created this drawing already. Now, okay, so it seems that the piece marking didn't work here. So no worry, because in this case, ah, you know why? Because um, in this part mark, I've noticed that in general visibility in view is none. Let's say prepared, and then this one prepared, and then click modify. Okay, so this one must now it's creating the piece mark to each and every element. So the 3D must not have this piece mark. So that's fine, because I can easily select everything here in the 3D, and then delete the piece mark here, because we don't need the piece mark in the 3D. So that one is only for our viewing purposes. So now you will see here, these have the piece mark, or I can say the profile. Okay, so this is the profile here. So it shows the profile. So this D20, because this one is a loose part, that's why it shows the D20. I can simply delete this anchor rod D20. Okay, so that should be fine. So yeah, I can delete this D20. So I'll just leave only the profile. So as you can see here, all the profile is there. Okay, and the dimensions are there. Okay, so this one doesn't have. Maybe I can just simply actually you can add the piece marking manually if you like. Okay, so okay, let me just show it to you how it's done. Mm, all right. So again, under this part mark, it's already there, prepared always. Let's say visible. Okay, so there you go. So you have already all the piece mark or the profile in the drawing. Okay, so now uh, having this drawing, we can also create some information here. Let's say for this one, this. If I want to create now a view, a blow up detail here, detail view. So let's say a blow up detail. So put it here. So since we're talking about a blow up detail, then we can just simply change the scale here. At the moment, it follows the same scale. 1:75. So again, you can double click uh, on the on the view, or yeah, on the view properties here, to get the view dialog box here, and then we can change now Okay, so here, in this case, we can change the scale to 1:25. So it will be multiplied by 2. All right. Or maybe 1:15. Much bigger. Okay, 1:15. So in this case, I can just simply maybe we'll yeah, we can delete this D20. Okay, so leave it there. So now uh apply and okay. So now once we have this, um if you notice here, whatever we get from that particular view, so it already captured here, but and then we can change the scale. Okay, let me just why it's not applying. Okay, so apply and then click OK. So just hold on for a while. I think my computer is okay. All right, so now look at this one. So if I change here, if I extend this one to this, I stretch it here. So look what will happen to my detail. So I still get the same. So if I stretch this one here, so I get I get the view stretch out. Now, since this one is a detail, you can also you can also add the more information. Let's say, for example, we want to add the reinforcement detail here in this detail A. Sorry, I forgot uh, to update earlier. Now I need to open it. I need to open the dialog box again. Sorry for that. So okay, so now I can use my reinforcement here, and then here visible, and then you put here double lines and then modify. So you can see here it will show the reinforcement now. Yeah, okay. And then uh and then we can now use the section view here. Section view. So let's say this is the range of the section view, and then you put it here, and then look, this is the section view. Okay. So as you can see here, even though you're in the 2D, you don't need to draw the details that you need to see, but you can just simply make a detail view or section view, and then you can also add some more information. Let's say, for example, dimensioning here. You can add dimensions from the center. Yeah, so dimensions here. So something like this. And then let's say, for example, let me just get one rebar here. So let's say this rebar, if I add mark properties, so this one is 34 pieces of T8. Now if you double click on this one and then change let's say add a pull out picture, if you want to see the rebar here with the dimension, click OK and then modify. So see here, this is the graphical representation of that reinforcement. Okay. So this is how you create now, how you create the general arrangement drawing or the erection drawing. Now let's move on to the shop drawing, the fabrication drawing. So which is the most important part, because of the details that it will give you is the more detailed. This, because this is what the fabrication will need. Okay, so let's start with a column. So this column. So I'm going to the drawing properties and then cast unit drawing, and then here let's say rebar, apply and okay. So this time around I'll go to the document manager. So if you look onto the document manager on all drawings, so I created already the drawing document here. Now this time I'm going to create now the cast unit drawing. And then here cast unit drawing. So open this. So again, I did not do anything, but the system create the drawing for us. And look at the drawing that the system created for us. See this? Automatically it creates the drawing, the fabrication drawing with all the dimensions. See, with the bar bending schedule as well here. Look, there is a bar bending schedule and even the graphical shape code here. Okay. All right. So let's try the beam. I'll close this one and let's try the beam. All right. So beam, select this beam and then create drawing again. Cast unit drawing. All right. So here you can see the cast unit drawing here. Again, this one is for the beam. Sorry. That one's still the column. This one, other one. Okay, so this one is for the beam. So as you can see here, you have all the T8, 1T20, 2T20, and there's an opening there. Okay, so this presentation can be changed if you like. Okay, at the moment this is the default one, but this one can be customizable. And for the steel, okay, for the steel, I'm going to create a drawing for the column and for the let's see. Hey, where's the uh, okay, I close the view. So let's say the column. So I'm going to create the column, this column, and then the raptor. So maybe I'll use the drawing properties and then assembly drawing. So I'll call the maybe beam with parts, apply and okay. So select these two and then create drawing, assembly drawing. So if it is a concrete, we call it cast unit drawing, and then if it is if it is a steel, we call it an assembly drawing. But it's similar. But the only thing is Okay, it looks like it's creating a lot of details. Okay, so here we can see here beam. Okay, let's open the column first, C4. Let's see what it looks like. All right, so quite nice because all the dimensions are there. So as you can see here, dimensions, the location of the clits, and then you have the welding. Actually, the welding you can because the welding. Sorry, I can just simply where's the this welding? Uh, Sorry. Actually, this welding I can clean up this welding because there's a lot of welding showing. Actually, you don't need to show all the weldings because if you have some reports, I mean some general notes for the welding, it can be done as well. But this standard welding we can remove it. Okay, so under this where is that one? Under the weld, uh, uh, eh? Yeah, it's already. hmm Here, sorry. The weld mark. Welds none. Modify. So we just turn up the welding. Okay. So this is the column drawing. Now let's move on to the beam drawing. So if you notice here, you have the detailed drawing, the cutouts of the base plate, the stiffener, the fitting dimensions, yeah, the gusset plate. So all the details are there. So imagine you don't need to draw that one by one. So if you're using the classic way of detailing, then it will take a lot of time. But in this case, the Tekla structure will create the drawing for you automatically. So similar thing with the rafter. So as you can see here, you have the uh, you have the location, okay, the dimensions, and all the and here this is the bill of material. All right, so yeah, so that one is the how the Tekla structure works. Uh, I mean the basic one, of course, the basic one. Uh, then if you like to have some, if you like to use this model in your presentation, you can change this one to a perspective view and then modify. So this one is the perspective view. So once this one is in perspective view, you can just simply Control F and then make a walkthrough. Okay. So there you go. And also, like what I've said, if you want to have a multi-material, so let's say for example, you want to have a wall made of wood. So I can use the concrete wall here. Look, huh? So if I click here, this is a wall. but I can change this wall to a wood. So how to change this one to wood? By simply changing the by simply changing the material to a timber. Okay, and then here left modify. All right. So if I may do the opening here, polygon cut, select. Hey, sorry, polygon cut, select this one. All right, so that one is for the uh, wood. So look, now let's try if that one works. If it shows the wood part. So under this view, we have this visualizer and then visualize material type. So if I go to this timber, where is the timber? I cannot see the timber one. Timber, okay. That one is a timber. So click OK. So now, if you click visualize, visualize all. So this one is something like it will be rendered, okay, to the point that something like you can do some presentation. So as you can see here, so there's some, this one is steel, and this one is the concrete, this one is the steel, and this is the timber. So as you can see here, you can have this uh, presentation. Okay, so if you like to do some walkthrough, so I can make it. We can do something like this. Also here, you can change the shadow. Okay, here the lighting, and then all right. So this one. Okay, and then in this case, if you like to have some walkthrough, you can just simply make a plus, click the plus here, and then zoom in, and then plus, and then change the view, zoom in, and then plus, zoom in, and then plus, plus sign. So here, plus, plus, and then zoom in again, and then plus, and there you go. So plus. So once you click display, you can record a video and then use this one for your presentation to show your client, okay, this is the model that you need to do to use. Okay, so I think that's all for now. Thank you very much for your time, and we're going to send you the link for this session, so at least you can try. So Kai and Tan, thank you again for the time you spent for us. Okay, so hope to see you soon. If you have any question, just just let me know. You can ask now, or you can send us an email.